This conference will now be recorded.
Along with me, Narendra sir is there, and
Okay.
Cosmos coordinator, and Sridevi madam, she is also Cosmos coordinator, and Professor Sanjeev Kunte.
Okay, hello sir.
Sanjeev Kunte is there. Okay, you can address students.
Yeah, sure. Hi, good morning. It is good morning all students. So this is the first webinar that we are planning to do for our college where we studied. Okay, and myself Dhananjaya Padmanabhachar, and I can you able to hear?
Dhananjay, 1 second.
Yeah.
So, our coordinator will introduce you to the gathering.
Sure.
I ask Narendra sir to introduce our alumni Dhananjay Acha to the students.
Dear students, we have with us for this webinar two resource persons. The first person is Mr. Dhananjaya Padmanabhachar. He's a cloud practice head in IT company Bangalore, and he is having about around 15 years of experience in IT industry, as well as he is a founder of NGO Discussion Class Association. I welcome Dr. Dhananjay sir to this session.
Definitely, it's an honor and privilege to do this kind of session for the college that I studied. And thanks a lot, madam. I still remember the classes that we learned from you guys.
Thank you, sir. And we have one more eminent personality. It's Lipsa. She is having around 6+ years in IT, and most experience she has got in AWS cloud projects, and she is carrying rich expertise in AWS, and is also developing cloud and developer OS working with multinational companies in India. I welcome you, ma'am.
Hello, everyone.
So what is?
Yeah, thank you. Thanks a lot to Narendra sir and Nirmala madam and the entire Cosmos Department of Computer Science and JNNCE for these arrangements and to present whatever we learned in past couple of years in the industry. And let me just to brief you about how the session that we're planning to take. Okay, the first session will be kind of introduction to the industry market trends, and just to give you a brief about why the cloud computing, the word cloud has become so popular in the market, and why the industries are looking towards cloud computing as a new digital horizontal technology by itself, so that customer can adopt to it. And then we'll go into understand the basic fundamentals of cloud computing, and then explore multiple cloud providers in the market. One is AWS. Today it is very difficult to cover all the cloud service providers, so probably we can do it in a series of webinars. Today we are going to touch base on one of the important leading cloud service provider, which occupies more than 50% of the market share in the industry, which is Amazon Web Services, right? And also we'll walk you through a couple of some important services available in cloud computing that will make you hands-on, and then also help you to create your own cloud account, right? So that you can experiment by yourself and what kind of different projects that you can look in the cloud technologies. Then we'll end the session, right? So before that, I just want to give a brief about discussion class association, where the program has been conducted through Cosmos and JNNCE. Discussion Class Association is an alumni association of discussion class students, where students will learn by themselves, right? It's a very powerful peer learning technology implementation organization which is spread across all our country. okay, which was started in Shumaga and Bhadravati. Bhadravati is the base origin, and it has been started in Shumaga also. And right now it is spread across all over Karnataka, and students are carrying this methodology. You can also experiment where you can take classes to your own batch of students, right? So that's a brief about discussion class. And I will move on directly to the cloud computing. So for now, let me pause this screen. Okay, so today's I already covered the agenda, and then let me go on. 1 second, what happened? Yeah. So if you look at the market trend, what is happening in the industry, the worldwide IT infrastructure market forecast in terms of the percentage of utilization has been depicted in this picture. So 60% of the market infrastructure has been, occupied by the traditional data center. So what is a data center and all will be covered in the later section. So imagine you have an application where you have HR management system or library management system, all the books to be managed. And when you develop a code, if you want to develop at an enterprise level, you need a space, you need a data where the application will be hosted, right? So that data center business was around 60%, and then gradually it is getting reduced to only almost less than 40%. And then the adoption of cloud has increased over a period of time, right? So with respect to numbers, if you look at the numbers, what is there in the market, it was $42 billion business on BPaaS and platform and services like that. Overall market capital was $145 billion. Okay, this is a market capital that the customers are looking at it. See, the reason why this numbers is important, because this is an opportunity for students when they come out of the college and start working in companies. The company strategy is moving towards cloud, right? So that is why we look at from 2017 at 145 to it has reached a stage where we are at $206 billion business industry, and then it is going ahead till 278 as per the prediction which is Gartner given in 2018. Right? So the traditional way of developing an application and the traditional way of deploying an application on data center is slowly degrading and slowly it is vanishing. Right? So that is why the concept of cloud computing is emerged, very powerfully. If you look at adoption in different industry, I think it may be little difficult to understand at a student level. But if you look at the financial services, banking sector, or insurance agencies, companies which are adopting cloud, and then also in terms of healthcare industries and financial insurance companies, they're already moving ahead from basic cloud to an advanced cloud from a virtualization. I think I'm assuming that everybody understand what is virtualization. Whatever the hypervisor that we put on top of your traditional server and make the resources shareable, right? So, for example, VMware is in the market, and then you have Hyper-V in the market. So, you put an hypervised layer on top of the hardware to make your resources available on a multi-tenant model. That's virtualization coming to picture. From there, adoption of cloud has increased from virtualization to basic cloud and advanced cloud, where the applications are developed for cloud itself. So that is where the industry is adopting. When it comes to fundamentals of cloud, it is very very clear from the industry market trend where it is adopting. It is on-demand IT delivery resources and applications over the internet, which is on a pay-to-go model. So I want to give a just example of what you mean by cloud computing, what you mean by pay-as-you-go model. Suppose everybody will have a current power at a house, right? So the way, if you look at the model, how it is the the BESCOM or the service provider charge per house is that they will have a slab based pricing. So suppose you consume 100 200 units, 0 to 100 units, you will be charged at, say, for example, 4 rupees per unit, right? So suppose you consume 200 to 100 to 200 units, they will ask another 5 rupees per unit, right? Like that, any compute resources, any storage resource, any resources that is available on demand can be charged on a per pay use model, right? So that is the basic fundamental of charging the customers based on how you going to consume in the market, right? Uh, that's an example that given electrical services analogy. And then with respect to different public clouds, whether it is a private cloud, a public cloud, or a hybrid cloud model, I want to hand over to Lipsa. She is around 6 to 7, 8 years of experience. She worked with me in the past in multiple organizations. And then right now she is working in one of the leading company in Bangalore, AWS architect and a DevOps architect. She explain us what is public cloud, what is private cloud, what is hybrid cloud models that is available in the market, and what are the different service providers in the market, and also talk about AWS fundamentals, and also walk us through some of the services. And both of us will be online, and then any questions that you have, you can make a note of it, and then we can answer it to your questions whenever it is required. Probably I want to stop the questions till the end. Probably we can keep last 20 minutes for Q&A sessions. If you have any questions, please make a note of it, and then we can address at the end. Okay. So Lipsa, handing over to you to address cloud, public and private hybrid cloud models.
Hello, everyone. Before I start on explaining different type of cloud models, I would like to express how excited really I am when DJ mentioned to me that I'm going to take this training for you all, this cloud basic training. I usually take the in-house training for the organization I'm working for, the employees over there. But when I got to know that I'm going to give this presentation and training to college students, I'm really excited to interact with you guys and share this cloud knowledge and journey with you all. So moving on to different type of clouds, I'll start sharing my screen. Let's just do that. DJ, could you please make me present? Thank you.
Yes, please go ahead.
Let's go.
Yeah, we are able to see your screen.
Okay, so to understand about public and private and hybrid cloud, these are different type of cloud deployment models. So what does it mean by cloud deployment model? It's like how you are configuring your cloud environment. Let's say on a traditional environment, like how it used to be before the cloud came up, as DJ mentioned, there was virtualization which came up during a later part of time, and then people started sharing the resources, compute, storage, networking, security. All these resources were shared virtually across in a distributed environment in an organization. um, then uh, in that network it forms a private cloud, because the resources means the machines, the computers, the disks, hard disks, or network devices, or security resources, or people who are working for it. All the resources belong to the organization where it is confined with. That is a best example of a private cloud. The best example you can take is, let's say in your college itself, you have multiple computers connected to a network, and might have a configured a domain of yourself and multiple computers connected in that domain. So that's itself is a private cloud for you all. So when the cloud concept came, then it no more remained within the organization. Different cloud vendors like Amazon Web Services, Azure, which is of Microsoft, IBM, and Google Cloud, they came up with ideas like, we will have the hardware, we will provide you the compute resources, storage resources, and all the other resources that you will require for your environment, for your organization to run, and you connect remotely via internet or via directly having connection to the cloud, and then work on our platforms. So the platform and everything else is being provided by the cloud providers, the cloud vendors, and we as a consumer use them. As an organization, we will be at the consumer end. So in this case, what happens is we don't have to maintain the resources that we will be using, like the computers, the softwares, the security softwares like the antivirus, the electricity, all these things that we will have to maintain. We don't have to worry about all these. So now these all is being taken care by the cloud provider. Why it became public cloud, why it is termed as public cloud? That's because the platform they provide us, where our compute resources, when I say compute resources, it means your machine, a normal system that you are using, where all your where all your programs or applications, everything that run exist. So all the compute resources and everything, it's not only it's not only us who is going to use it. There will be multiple tenants. Like, let's say I as an organization, or Dhananjaya, or you, multiple organizations will share the same platform. So it becomes public for a lot of organizations. But yet there will be security maintained for all of for each individual organization. And yeah, that's just a brief of how public cloud is working. Now let's understand about hybrid cloud. Why it is called hybrid? It's because it's a combination of public and private, as you can see, very basic, normal. But the reason this hybrid cloud came into existence is because there, when you want to move all your applications from your existing environment to cloud, let's say you are running a company, you have multiple applications running, maybe your in-house employees you are accessing those applications, or maybe public as end users are accessing those applications, and you want to migrate those applications to cloud. Or the second scenario, you want to build an application in the cloud itself, but there might be a situation where you don't want to keep all your data over the cloud, maybe for a security point of view, or maybe that is something non-disclosable information, and you want to keep them in-house with you. Whenever it is required, maybe your cloud resources can access them, but you don't want to all of your those private data, those secure data, to exist in cloud. Or this is one situation. Second situation, maybe you are using some applications which are not yet available on cloud, some components of your application, some softwares or something that is not yet being hosted on the cloud or being provided by the cloud providers. So these are the situations where you're bound to keep some of your resources on premise and have some of your resources on cloud. So that's how the hybrid cloud concept comes in. So the resources of which are or your on your on-premise, that means within your company premises, within your organization, in your power, and in cloud will be connected via some network or via internet. Then, however, there are different connection models which are there. I'll be talking about in eventually. So yeah, that's how the hybrid cloud concept came in. So private, public, and hybrid cloud. Yeah, this is just a pictorial representation of how public, private, and hybrid cloud works in a real life, like private and internal, then public, and yeah, hybrid. Now, different type of cloud offerings, which is IaaS, stands for Infrastructure as a Service. PaaS, PaaS, Platform as a Service. Then SaaS, Software as a Service. The reason, again, I'll go individually why these different type of cloud offerings are there. Let's go to the details of it. Okay, let's first understand on the first column. Focus on the first column, please. In a traditional IT environment where all these cloud concept was not there, when you are running everything on your own, you have your compute resources like your systems, your computers, desktops, laptops, or other source of computing resources on yourself. You're maintaining those yourself. You have your storage, which is maybe your internal disks or attached disk volumes or hard disks, or you're maintaining racks of storage, the different servers, the different server machines. Then you are maintaining all your virtualization, different operating systems, Linux, Ubuntu, yeah, RHL, Red Hat, Ubuntu, Windows, any operating system that you're configuring for your systems. Then middleware applications, you might be hosting multiple applications, so you may be maintaining your middleware applications on them. And data, whatever data will be there. And on top of that, the applications with that on the your applications which you are hosting on your environment, maybe for in-house or for the public as end users. So all these you have to maintain by yourself. So you manage. So nothing is being managed for you in a traditional environment. That's what is the real picture. Now let's move to just one step ahead, infrastructure as a service. In this, what as a consumer, as an end user, you'll have to manage the upper section, that applications, data, runtime, middleware. I'll come to that. Let's first discuss about the second half, operating systems, virtualization, servers, storage, and networking. So in this, the infrastructure is being provided by the cloud provider, like the bare metal on the platform where your operating system will be there, where the RAM storage will be assigned to you, where the disk volumes will be given to you, storage, where you will configure your environment, your servers. Maybe that is Windows or Linux or whatever server you want to configure over there to host your application. And on the bare metal, the cloud service provider provides the virtualization. They install a hypervisor. They maintain that, which is why the resources are becoming virtually available to you all. And the operating system, the patching and everything is being maintained by the organization, the cloud provider itself. But you as a consumer, as an organization, will just have to maintain your applications, your data, runtime, how much you want to run those, how much time you want to run or however you want to run, and the middleware applications, however, your application configurations that you will have to, do. Now let's move to the next step, which is platform as a service. So in this, there will be even lesser things that you will have to manage as a consumer. So just along with everything else, add the runtime and middleware. So the middleware, like on the on the platform where it will be running, like if it is a Java application or if it is a database application, anything. So the application, the platform, wherever your programs will be running, will also be taken care by the cloud providers. In this, the I mean, the only thing that you'll have to manage is your applications, that your built applications that you have developed or you will be developing will be, you just have to manage that, and then the data. Now let's move to software applications. The best example, before I explain why all of these is being maintained by the cloud provider, is because, okay, let me give you an example. Is your simplest is your Gmail. You just go ahead and log in and access your data. But have you ever thought about where the mail server is being configured, where all your data, your password, your username, email ID, or your personal information, date of birth, place, age, and everything is being stored? How the computation is happening, how you're accessing, you're archiving, you're deleting, you're maintaining your calendars, all these things happening. Everything is happening at the back end and it's being taken care by somebody else. All you're doing is just logging in and enjoying the service of that is being offered to you. So this is a software that you're just using, but everything else is being maintained by the provider. So that is the best example. So app starting from the storage, compute, networking, server, security, virtualization, operating system, middleware, application data, everything is being maintained by the cloud provider. All you just have to do is you use the service, consume it as a service itself. So that is how the cloud concept came in. The cloud concept is being provided as, I mean, instead of you maintaining the resource by yourself, why not you use them as a utility and let us as a cloud provider maintain that? So that's where it came in the pay as you go model, which DJ mentioned first in the first half. So you just use them as a utility, use them as a service, and pay for what you have used. Let's say the electricity, how much you have consumed, pay only for that, not for the entire month. Okay, for a month, this is the plan, and you have to take this much. No, there is no upfront money you are paying. So how much service, how much amount you are using, only pay for that. So this is just again a pictorial representation on a real life how it is, end users, application developers, network architects. So infrastructure as a service is the best example where IaaS is the best example where architects and who architect your environment are working on IaaS. Platform as a service of application developers are the people who mostly use PaaS kind of environments, and SaaS again as end users we just use it and don't bother about anything else. Okay, so there are different kind of cloud service providers. Amazon, which provides Amazon Web Services, AWS. Then there is Azure, which is by Microsoft. And then there is Google Cloud, GCP, Google Cloud Platform, which is being provided by Google. There are a couple more. IBM is coming up into the market, but now the major leading companies are like Amazon and Azure. Then Google is catching up, then IBM, other cloud service providers are there. What are the best benefits of using cloud computing? Let's discuss about that. So the best benefit of cloud computing is, first thing, no upfront expenditure, no capital expense. So you are not paying a big amount to use something as a service for a longer run or for a period of time. You are paying for what you are going to use. So you optimize your environment, how you want to use, how you want to make the cost saving. That's all. No upfront investment. Second thing, scaling. Benefit from massive economics of scale. So how scaling? There are two types of scaling: vertical scaling, horizontal scaling. Horizontal scaling means, let's say you are having you just have in your family you just have one computer, then you are sorry, in your company you are having one computer and you are maintaining multiple applications on it, and then you came to know that okay, this system is not enough for it's incapable of serving the purpose. So then you wanted to add more, so you added more computers, more storage. So that when you add more resources in numbers, that goes as virtual scaling. Horizontal scaling. But cloud provides vertical as well as horizontal scaling on the fly in fraction of minutes or seconds. How is that? Because if you have a resource, if you have a computer, virtual machine, which is a computer on the cloud, and that is just one example of scaling, but every other service can be scaled, I mean is scalable. I'm just talking about compute resource, which is a virtual machine. So let's say your virtual machine, you created a virtual machine of certain capacity and a certain with certain RAM, with so much of RAM and 2 GB or 3 GB, 4 GB, 8 GB, how much it is, and then you have some hard disk volume to it, attached to it. Then you realized maybe the RAM or the storage is not being enough, the disk volume is not being enough. So you can scale it, you can add on the fly, you can change the machine type, and on the fly the scaling will happen. Likewise, the networking and security and all of the resources, some are scalable by some are being scaled by you as a user, and some will be scalable and some will be scaled by the cloud provider itself. On the fly they scale. And yeah, that's about scaling. Let's move to capacity cases. You don't have to first be very hard and fast about deciding on what should be your to be environment's capacity. I mean, it will be obviously a mad decision to not think about a capacity and then provision your resources over the cloud. you have a rough figure on your mind, but you don't have to be very worried about, okay, these many machines we have, if we need more, this much time will be taken to procure all these resources and time. I mean, you don't have to worry because you can scale vertically or horizontally on the fly within fraction of minutes or seconds, and then so capacity guessing becomes very negligible on cloud environment. Then fourth point is increasing speed and agility. Yeah, agility, I mean, the flexibility, the quick you can change your environment is there in cloud. How it's a point which can be only experienced by examples and by working in the environment. Just to understand that, yeah, speed and agility is one of the best factors of moving to cloud. Stop spending money. I mean, fifth point, stop spending money on running and maintaining data centers, because you're not maintaining your own data center, you're not maintaining your own computers, you're not maintaining the electricity that is required to maintain those computers. Again, you're not installing the security softwares like antivirus, or you're not having much of people who are going to work on those resources, like on those computers, or maintain those resources. So all these maintenance costs you can save. And then go global in minutes. Yeah, this is the best fact of cloud. You are in India, but you can create a machine in America or in Australia or in Singapore or in China or wherever you want, wherever your target end users are, and you won't have to go for months or years of time to establish a network over there and have the end users be able to, consume that service. You can create resources, you can procure, which means provision resources anywhere in the world, and have your end users be able to use them. So yeah, those are the benefits of going to cloud. um, Now, my dear friends, I would really request you, because now as we go on talking about a lot of stuff, uh, it's human nature, you won't be able to remember all my sentences that I'm talking about, everything that I'm going to explain. But I would really appreciate that in between I'll mention some keywords, and if you'll just make yourself familiarize, or just have a hint in your mind that, okay, this is the word and this is the meaning of it. If you'll just have those things in your mind, later in future, where in case you happen to be fortunate enough to work in a cloud environment, or move to do internship or whatever, however you will be involved with your cloud environment, it'll be easy for you to just to transition to that and get on working. Like I mentioned, few of the keywords in just before, like infrastructure as a service, platform as a service, software as a service, IaaS, PaaS, SaaS. And then I mentioned public cloud, private cloud, hybrid cloud. There are, like, yeah, 6 7 key terms are already there. Have yourself familiarized. In future, if you are going to Google it or have something researched, you'll find your keywords or place where to start from. Okay, now let's move to AWS core infrastructure and services. Okay, as I mentioned, there are multiple. Almost now, the cloud providers have become mature enough to be able to provide you services on almost all the areas, almost all the nooks and corners of the places where an application environment will need a component from. What I mean by that, the, the basic components that you need is a compute resource, a machine where things will be running. You need a processor, you need some RAM space, CPU, and all that. So yeah, a computing resource, storage, uh, the primary storage, which is like your RAM, and then secondary storage, which will be your ROM disk volume, and there will be some extended disk volumes, which is like you have your external hard disk, similar storage, and networking, security, network, how your environment will be connected to each other, security, how you will maintain the platform security, the infrastructure security, as well as user and access management security, networking. In all these areas, cloud providers do provide different type of services. So now you remember two key terms: service and resource. Service is the facility that is being given to you. Resource is the entity which you provision or you procure of that particular service. Let's say, for example, AWS provides compute service as EC2, Elastic Compute Storage. Sorry, Elastic Compute Cloud, EC2. So again, one more key term. AWS provides EC2. EC2 is the service. Now the resource is EC2 instance. So in AWS terminology, it is called instance. If it is a different cloud like Azure, those are called VMs, virtual machines. But in AWS, we call them instance. Make yourself familiarized with these terms when I'm talking about. So EC2 instances you create in the EC2 service. So service is EC2, you create the EC2 instance. When I move to the demo part, you'll be able to understand and correlate. Similarly, AWS provides Amazon S3 for storage, S3 for simple storage service. These are the key terms, okay? Amazon RDS, relational database storage, the database like you maintain on your on-premise environment, data centers. Similarly, service is Amazon RDS. Then you create RDS instances. S3 is the service, you create storage buckets. Buckets are the resources. So yeah, these are the services being provided on cloud. But what for these are being provided on the left, if you'll see on the bottom line left, there is SAN, NAS, RDBMS. These are the multiple storage and database options that we maintain on a traditional data center. And on cloud, the parallel resources are like Amazon EBS, Amazon S3, RDS, EFS. Okay, so similarly, in terms of servers, on-premise, you maintain your servers, and on AWS, you maintain EC2 instances. EC2 instances like you can have use them as individual machines or as servers as you can create. And AMI, Amazon Machine Image, is a term you'll be able to understand once I move to demo part, because all I can say is like, when you install a operating system on your machine, you have those image disks that you install on a machine to first get it running. It has some basic softwares and the operating system. That is what is being configured in an AMI. It's just a JSON template which has the information about the operating system and some of the system configuration softwares. Now talking about networking. On your on-premise or in data center, you maintain routers, network pipelines, switch, and in AWS, you maintain VPC, subnets, security groups. So the AWS terms are VPC, Virtual Private Cloud, subnets are subsections of your network of a VPC, and then security groups you will maintain. So security group is part of your network, then it is more of a firewall. So that is why it is being mentioned in security section. So for security on your data center on a traditional environment, you maintain firewalls, access control lists, firewalls for to have a check on your network flow, access control lists, who can access what resource on your environment, administrators who will be maintaining your environment, maintaining users and defining users and groups with different level of accesses. So the parallel the mapped resources on AWS is like security groups for firewalls, NACLs, network ACLs, network access control lists, doing the similar job. What resource can be accessed from which IP range, which should be allowed, what should be allowed, what should be denied. Then AWS IAM to maintain the user and access management, identification and identity and authentication management. Okay, IAM, that's what it stands for. So take a take a little time to familiarize with these terms: EC2, S3, RDS, AMI, VPC, NACL, security group, IAM. So these are the terms which will be, somebody mentions or you go to an environment where you work from, it rings a bell. You find yourself comfortable, not very strange kind of thing. Okay. Web service, Amazon Web Service. Yeah, this is Amazon Web Service is being provided by Amazon. It's a web-based service. As a service, it's being provided to you via web, which is using which you can build scalable, sophisticated applications on the cloud. Um, Okay, when I mentioned just a while back that Amazon is not only Amazon but all the prime cloud service providers, AWS, Azure, or GCP, Google Cloud, everybody is providing multiple services for different purpose, for different kind of facility that you are going to use to maintain an application. So each for each of these things, AWS, talking just about AWS, it provides different services. EC2 for compute. Inside of EC2, there are multiple sub features like VPC, there is EBS, there is EBS Elastic Block Storage, there is VPC, Virtual Private Cloud, there is other things. So like EC2, there is a service, there is multiple sub services which are being provided. Similarly, other features are being provided in terms of other features, other services. Other features are being provided in terms of other services, like for storage, it is S3 extended storage, which is S3. Database is being provided by RDS and DynamoDB, EFS. There are hundreds of services. Then altogether, it becomes thousands of features which is being provided uh, as a sum up. So, okay, instead of talking about this page, I'll just show you how in real it looks like AWS service. This is the AWS console that I have logged in. When I'll present the demo of how to start working with AWS, I'll show how you can get inside of an AWS account, how you can create, how you can start with it. As of now, I'll just start with this console just to give you an idea how it looks like. Once you log into the AWS console, it's called console, AWS Management Console. So you all might have shopped from online from Amazon.com. So just add aws.amazon.com just before it. That's what it's cloud provider. So go to aws.amazon.com and then you can register, which we'll discuss later. So yeah, this is how the normal AWS environment looks like. When you once you are inside of the console, when you click on services, it provides you the plethora of all the features, all the services AWS provides to you. But don't be disguised. Just EC2 is not just EC2. Inside of it, there is a lot of things. So similarly, each service has multiple sub features inside of it, which is why even though it looks like hundreds on this page, there are multiple sub features which are available with it. So let's just speak into just one service, EC2, how it looks like. So this is a service. This is the facility that is being provided to you as a feature. You still don't have anything in it. No resources of yourself is running here. You need to create them. You launch your instances. That means create your virtual machines in the cloud, which otherwise will act exactly like a system that you are having on your data center, that you have access to do your stuff. It will behave exactly like your laptop. So yeah, that's how AWS service page looks like, and these are multiple services which are being provided by AWS. Okay, let's talk about how we are connecting to the Cloud Console. So as you saw on this page, I went to aws.amazon.com, then I logged in. That's when this address bar translated into this different address. But I connected to this via internet. I don't have a LAN cable or anything that is connected to the cloud provider. And where this AWS platform is being hosted and where everything is, I don't have any physical connectivity to there. So I'm connected via internet as of now to start with. When you start working with AWS environment, you connect via internet, but inside of the cloud, whatever you work on is very secure because they are maintaining on the bare metal itself. They have their own security applications installed. They have defined network, different firewalls they maintain, what traffic can come in, what traffic can go out. All these is being maintained over there. So via internet, we connect from our laptop or whichever web browser or mobile client, and you connect via internet to your AWS console. Okay, on the AWS platform, there are different type of different areas where the services are being provided. Rather talking about this slide, I'll just switch to this web page and show you in real how it is. So let's talk about compute. That gives you the processor, the CPU, the RAM, the primary device, the root volume, the external disk, the security, and everything. All this is being provided in the category of compute. So in compute, you have EC2, Lightsail, ECR, ECS, and multiple others keep adding up every year. This list may not be the same next year. So Amazon every year in their reinvent, they keep launching new services which keep on adding up. So when I started working, there were barely 30 or 40 services on this screen. Now you can see hundreds. So yeah, in coming back to the compute. So in compute, you have these all services available. Then there is storage. In storage, you have these options: S3, Elastic File Storage, FSX, Glacier, Storage Gateway, and all these options. Then in database category, you have RDS, Relational Database Storage, DynamoDB, non-relational database. RDS is for relational, DynamoDB is for non-relational. Remember that. Then Elastic Cache, which is again acts as a cache for databases. I'm just slightly mentioning about these things because we have very limited time and probably I won't be able to cover all these topics in detail. But the name should ring a bell to you, and you should be aware of, just familiarize with these terms. So yeah, these are the different type of areas where AWS provides services. Okay, so there are a couple more: analytics, robotics, business applications, end user computing, IoT, Internet of Things. You know how some of you might be, or all of you might be aware of the device nowadays is being used, Alexa, Amazon Alexa or Google Home, which can also connect to your multiple internet enabled or web enabled devices. Like you can configure your entire homes in connectivity, like you're starting from your oven to your refrigerator to your TV or anything. A lot of things that can be configured via internet to IoT device, Internet of Things device. So similar things are being used in organizations as well as companies. So yeah, database. Yeah, just to give you a rough idea, this is how in different categories services are being provided to you. Okay. Okay, before I move to this, I just want to give an idea on a couple things. In compute category, remember the terms EC2 and Lambda. Just remember these two, Elastic Beanstalk, yeah, and ECS. These are like 3-4 terms. Get yourself familiarized with EC2, Elastic Compute Cloud, ECS, Elastic Container Service, Lambda, Serverless Computing Service. Unfortunately, we won't be able to cover, but you'll get an idea if you Google it or try to find out. Elastic Beanstalk, you can deploy applications on the fly in the cloud, including in platform and in networking and everything will be taken by this thing. So in compute category, these are the primary services which are being used by any organization who just wants to move to cloud. They will definitely use EC2. They'll at some point will have to use Lambda if they want serverless computing and want to save even more cost on the fly. Elastic Beanstalk to provision, replicate infrastructures on the fly, and ECS to use the container service. Then in storage, remember S3 Glacier storage gateway, and in database, these are the primary services that are being used by any company or organization who is moving to cloud. RDS, DynamoDB, Elastic Cache. Depends if the company is using Redshift, DocumentDB, and all these, but RDS, relational non-relational database, these will be used for sure. And in networking, there is VPC, Virtual Private Cloud, Route 53, again, one of the major things to register a domain in cloud. And let me talk about just one more thing. Security and compliance. In that category, we have IAM, Identity and Access Management. Now, while explaining, I'll be talking about every other service but IAM. IAM, I'll talk about when I'll give the demo. Okay, let's switch back to the explanation part. In AWS, we have regions, availability zones. What else we have? Yeah, for now this much. Okay, in regions, what is a region? Again, another key term. Region, availability zone. In short, it is called AZ. So yeah, two primary things. So region is a geographic location and within which AWS has its data centers. So again, you must be thinking about if we are moving away from the data center concept, traditional concept, why again data centers? But somewhere it's using something, the cloud service provider is able to provide you the compute resources, the networking or storage or security, everything. Where is it all being maintained? Bottom line, it's being maintained by some at some data center. The difference is we are not maintaining the data center. It is being maintained by the cloud service provider. So in a coming back to a region represents a geographic location in which multiple data centers are there. So a geographic location, let's say about India, it can be India or America or Asia Pacific, like Singapore region, Australia. So likewise, let me show you how it is on a real cloud environment console. Here, on the top right corner, when you log into a console, the middle option gives you the regions. So these are the regions. These are different geographical locations where AWS, Amazon has its data centers established. These are the now 14 or 16 regions are there. Then in each region, AWS maintains minimum 2 availability zones, or it can be more. As of now, it's being more than 3 or 4 is being maintained. But yeah, minimum 2 availability zones will be maintained. Why? I'll come to that. Let me first explain you what is an availability zone. Availability zone is a data center. It's a building inside of which all the racks and racks of compute, your RAM volumes, your ROM volumes, storages, networking related resources, switches, routers, security applications, all are being maintained on bare metals in a single data center. This is a single location. Location, let's say, let's talk about, location means in one location, the data center will be there. And it is being maintained in one data center. That is one availability zone. So inside a region, all the availability zones are connected via direct physical line or cables, you can say. So that's why once your network traffic is inside a region, then it travels within the AWS network itself. It doesn't leave the AWS network to the internet. But I mean, inside a region, all the availability zones are interconnected network-wise, but all the regions are network-wise separated, isolated. So one region to another region connectivity is via internet. That's what you have to pay the internet cost when you're using. But within a region, the traffic stays within AWS network and the speed is fast. Yeah, connection wise, you can, let's say you have your the AWS as of now. Let's talk a practical example. AWS has a data center in Mumbai now. So that is region Mumbai and AWS Mumbai and where is it? Yeah, it's a Pacific Mumbai, and in Mumbai there will be 2 or 3 data centers, so which will be 2 or 3 availability zones, and those are interconnected. Um, but if from when you're hosting an application from your on-premise, from your normal organization premises, if you want to move data or the there comes a time when if you're migrating applications or you're migrating things into cloud, if the data the size is in terms of terabytes or petabytes of data you have and you want to move them to cloud, you want to host them in cloud, or you want to maintain them on your data center premises, but your cloud applications is going to consume the data to give certain output, then you need a better connectivity between your on-premise data center and cloud environment. Because as I told you, if you want to connect from your laptop or from your company premises to AWS console, you connect via internet. The network traffic goes via internet. But if you want to increase the bandwidth, and if you want a better uh, uh, what is that called? You want to transfer data, if you want low latency and better and secure data flow between your on-premise data center to cloud, then you can go for direct connect. Again, another key term, direct connect, you can use, which is again a physical network connection from your data center to AWS cloud. So yeah, I mean, that's how it can be connected to one of the availability zones, one of the data centers, and then from there again, AWS maintains high class optic fibers, which is very high bandwidth within the AWS network itself. But talking about from your on-premise data center to the AWS cloud is being taken can be taken care by direct connect, AWS direct connect. So yeah, that is about giving you an idea of availability zones, regions, and direct connect. Again, remember, regions are network-wise isolated, whereas availability zones are internally connected. So from one availability zones to other availability zone, you can communicate. So yeah, this is how, on a global level, from world map, you can have a visual on where the regions are located and how it looks like. Yeah, just rough idea. Inside a region, as I mentioned, there is availability zone A, B, C coming about. Why was the need in the first place to maintain multiple availability zones? Because for high availability, let's say one building, one data center completely went out of power, some disaster happened, flood happened, something happened in in a data center which made the data center unavailable of the cloud provider. So if you have all your resources, all your EC2 instances, RDS databases, or everything that is created in one availability zone, and that got affected by some disaster or something, some fault, then you lose access, you lose everything. So that's why for high availability, there are multiple data centers being maintained to keep a what to say, redundant images or replicas of your data, of your environment. um, and also you can have multiple instances created in multiple availability zones, so that you can scale or you can distribute your network traffic, your incoming network traffic between those two availability zones, so that if one availability zone goes down, one data center goes down, at least another data center is available to host the incoming requests coming in. And if you have more than two availability zones, that is even better high availability, better level of high availability you are providing. So this entire concept is called as multi-AZ deployment, multi availability zone deployments, which you will see. I mean, in EC2 you configure it by yourself. AWS doesn't do it for you. But in case of RDS, it asks you while you configure a database, it will ask you relational database when you will try to create. It will ask you, do you want to create a replica in another availability zone, or you want to maintain multi-AZ? Then if you select yes, it will create a replica database in other availability zone, and otherwise not, based on how high availability you want. Okay, now let's talk about how the region or availability zone endpoints look like. Endpoints means, I mean, how you refer them while you use them on your environment. Time 1:38. Okay, so a region is called like US East, and available US East 1, that is AWS. I mean, talking about just one region as of now, let's say North Virginia, AWS, US East, which is North Virginia. So that region endpoint is being known as US East 1, US hyphen East hyphen 1. It can't be dot, it's hyphen. US hyphen East hyphen 1. And availability zone will be represented as 1A. The other one will be 1B, 1C, 1D, 1E. And in the backend, to give you a backend idea how it is actually working, let's say in Mumbai they have 3 data centers. Talking about just a rough idea, they have 3 data centers. Doesn't necessarily mean a data center is having a name like 1A. 1A, 1B, 1C is on the fly. But you just choose the availability zone. 1A or 1B or 1C will be assigned the name for that availability zone for that particular period. I mean, like configuration that you will be doing as 1A. But doesn't necessarily mean this that it has 3 data centers, 1, 2, 3. Doesn't necessarily mean the first data center 1 will always have 1A as the AZ name. So that's how it works in the backend. So yeah, to give you a rough idea, that's how it is. So the multiple availability zones can go like 1A, 1B, 1C, 1D, 1E, 1F. That's how it goes. Similarly, there is a different region, Asia Pacific, to give you an idea about how a different region will look like. The region endpoint name is AP hyphen Northeast hyphen 1, and the availability zones will be like AP hyphen Northeast hyphen 1A, 1B, 1C. Again, to just give you a recap, availability zones, multiple availability zones is being used for high availability. Remember that. For high availability, use multiple availability zones. If anybody asks you why multiple availability zones is being used, for high availability, provide high availability. Because when you are hosting an application, you can't just rely on just one particular resource, one particular data center. If anything happens, then your global end users will be disappointed. Everything you'll lose access to it. So yeah, AWS storage service, Amazon simple storage service, S3. Okay, I'll come back to it. Security. Okay. So let's talk about service-wise. First service we'll pick is EC2. In compute, we'll pick EC2. In storage, I'll talk about EBS and S3. Definitely, it's impossible to give you an idea on all the services. Then on database, I'll talk about RDS. On networking, I'll talk about VPC. And on security, I'll talk about IAM. Before I talk about the services, I would like to give the demo so that how you can get into your console. Then I'll give you a tour of how the service works, how it looks like, and everything. Let's go to, come on. Bear with me, my system is a bit slow. At least it's acting a bit slow. I'm going in a bit of non-traditional training method because usually people keep the demo part to the last, but I realized by the time I end up, I finish explaining everything and I'll just show you, okay, this is how it looks like, this is how it looks like, considering our limited time, that won't be possible. So I'll just straight go merge the demo and the service part, okay? So once you go to aws.amazon.com, it gives you the option sign into the console. But do you have an AWS account? I have, but you don't. So when you will be creating, keep in mind you need a credit card. If you have one, use it to create an AWS account. Again, be very careful because the services you are going to use comes with a cost. Again, as a pay-as-you-go model, but still you have to pay a cost to use the service. When you create an AWS account, there is a free tier that comes for a 1 year period of time. There are some resources that you can use as part of the free tier. Google it, AWS free tier. You'll get an idea what all resources you can use. Create an AWS account, use a credit card to create one, and take the liberty of, have the liberty of using the free tier for 1 year. Then you'll be paying, but 1 year is more than enough for you to, exercise and experience all the services and get yourself expert on AWS. So let's go to AWS Management Console. If you don't have an account and you want to create one, I'll show you how you can do so. So, um, okay, it'll come either as the different option or create a new AWS account. Go for the option create a new AWS account. Provide your email address that you want to create the AWS account with, and provide a password for your AWS account, confirm password, AWS account name. Account name, I give that. Remember, when you create an AWS account, your account will have an account ID, which is a 12-digit number, which is globally unique for any AWS account, any country you create. It's globally unique, and so that is what will be the identity of your AWS account, not the account name. Account name is just to have a familiar, name, like you have a IP address, then you have a application name, so like that. So full name, then company name, and the rest of the information you provide. Then once you provide all this information, it will take you to a page where you have to provide the payment information, the credit card information, to which every month the bill will be billable to, and you will pay the rest of the pay the bill from there. So I'm not going to the next step because just to give you an idea, I came this far because I already have used my credit card in my in my previous AWS account that I was demoing with. So I can't use the same credit card again for a different AWS account. But if you want to explore and try things, sure, go ahead and try for this option. Then in the next step, it will ask you for credit card information and all that. Then your account creation will be complete. Once the account creation is complete, you will have to subscribe for the AWS services, which will take for 24 hours for the other additional services. But the primary AWS services will be enabled for you the moment your AWS account is existing and ready. Uh, you can start using the AWS services. For a flexible use, just create an AWS account and wait for 24 hours, and then start using it. Okay, now let's move to the AWS account existing one, how it behaves, how it acts. I already gave you a tour how it looks like, the AWS console. When you go to the AWS page, it normally looks like this. Then you go to services. Let's first talk about the service EC2. I have very limited time. Okay, EC2. EC2 is the primary compute service that is being provided to us, using which you will be creating your virtual machines, which again in AWS terminology called EC2 instances in cloud. So how you can create that? Go for the option launch instance. There are two ways you can do so. You can, if you are on the main EC2 page, go for launch instances option, or else you can, on another page, instances page, I opened that on a different tab. From that also you can create. There are multiple options provided on multiple pages. However you are comfortable, or wherever you are at, go from there. Launch instance, but the instruction is same, launch instance, but the option is being available in multiple pages. So let's go by launch instance. So remember, we're creating an instance on AWS, which can be an individual workstation or a server for you, and you can access them. Okay. As of now, to give you a demo, I'll create a Windows instance. You can create Linux instance as well. Trust me, the AWS documentation site gives you word by word. Even a kindergarten student can just go ahead and understand how the resources can be created, how you can connect to those resources, how you can secure them, troubleshoot, and all that. So let's just, okay, what came up? Sorry. I'll just create one Windows instance, Windows server. So go for 2016 base. You can use anything. Okay. This is what an AMI is. Amazon Machine Image. What does it have? If you see, it has the operating system version, operating system details, and which region it is in, what basic softwares comes along with the operating system. All that information is being stored in the image AMI. So AMI is nothing but that's just a template in which all these information is being maintained. Select the AMI and then go by the rest of the steps. Configure the instance. Here you choose the instance type. What instance type you should select? You can, the AWS provides a page where you can get the information. And here also you can take an idea what you're getting per instance type. In instance type, what are the CPUs, how many CPUs you get, how many RAM you get, and performance, network performance, all that. Based on these, you select the option you want to go for, configure instance details, select the VPC in which you want to create the instance. I'll talk about VPC. Let's just go by now how it is. And you can select which availability zone you want to create your instance in. At a time, remember, you can create an EC2 instance in just one availability zone. You can select the availability zone in which you want to create, or you can just go by no preference. AWS will choose it for you. If you have certain requirement, okay, your EC2 instance has to be in this availability zone because all your other resources are in this one, or if you have certain recommendations, go ahead and select on your preference. Otherwise, go by like that. If you want to have a public and private IP, again, this is part of VPC. You can have a public IP or a private IP. If you have an idea, I mean, I'm sure in engineering they explain you some networking basic stuff where you get an idea of in a networking environment in a domain you have you have subnets in which you can maintain public and private IPs. Public IPs can be accessed from the internet. Private IP is for internal domain environment, and you cannot access your resource from outside from internet through the private IP. And there are multiple options, to be honest, and it will not be possible to cover all of that. Okay, I'll just go with the basic as of now. Add storage, add tag. If you tag, these are kind of external additional information you can provide for your machine. Okay. Mhm. Mhm. As of now, I'm creating. Why all these options I'm going for? In an advanced AWS session, probably you'll be able to understand all of these. As of now, I'm just going with however the options are. So key pair name, I'll create a key pair. Remember, when you create a EC2 instance, make sure you download the key pair if you're creating a key pair. If you already have a key pair in your environment, you can select that one from the list. If you don't have one, create a key pair, download it. But remember, but creating a key pair is always not necessary. If you have your instances which joins to a domain, probably you don't need them. But if there is no other way of connecting to your resources and you need to connect to them from your on-premise or from your laptop or from another machine, then the key pair is the way you can. Or there is password method you can if you are configuring your RSA keys into your instances, then that can be done. Download the key pair, make sure to download them and launch your instance. One more thing I forgot to mention. You can create multiple instances in single go as well. As of now, I just selected one in the instance. I'll just give you an idea. You select the army, then you select the instance type, configure where it is, tax configure ads. See here, number of instances, how many instances you want to create. Here you can select how many instances you want to create. So it'll create those many instances for you. You can create multiple, more than one on a single go. So yeah, once this instance is created and ready, we can connect to it. In the meantime, it's getting ready. Let's talk about VPC, the network. Very important thing, because on your on-premise data center, you are maintaining your own network, which connects all your machines, all your storages to each other. But how on cloud it's all being connected? So on cloud, it is called virtual private cloud, which is a defined network area to interconnect your resources on the cloud. You can create multiple VPCs on AWS. In each region, AWS provides a default VPC, but you can create more than one VPC. You can create up to 5, and if you want to go beyond that, you need to raise a request to AWS, and they'll create for you. Remember, network-related resources, VPC and all, security-related resources, IAM and all, are free of cost. You can use network-related resources free. The incoming and outgoing traffic and the resources you provision inside of this network is billable, but using the VPC is free of cost. Using VPC-related resources, which is subnets and security group, all comes free of cost. So you have a VPC. VPC exists within a region, but the subnets, which is a subdivision of VPC, if you want to partition your VPC into multiple subnets, or you can have one subnet which covers your entire VPC. You can have two. You can create multiple for your VPC to have to just create multiple layers within multiple partitions inside of your VPC. Remember, VPC spans across the region, but subnet spans within an availability zone. If you remember this region and availability zone concept, subnets reside within an availability zone. When you create a VPC, you give a CIDR range. Again, I forgot about the CIDR. You give an IP address range for your VPC, and when you create your subnets, you create you reserve a small chunk of the IP range for your subnet. You can create multiple based on how many subnets you want to create. Plan accordingly, and then create your subnets in your VPC. Make sure you're not wasting any IP range, and yeah. there goes a little bit of planning behind that. Then comes the security groups. So security group is like a firewall. Like VPC, security group you can create for a VPC. So you cannot use a security group for multiple VPCs. So for one VPC, you can create one or more than one security groups and define how you want to control the traffic. As of now, if you see, this is the security group which I just created along with my EC2 instance. In this, I am allowing RDP protocol,
Okay.
and that is being
Lipsa,
allowed by,
Lipsa, 1 second.
yeah.
Just wanted to compare the subnets with and security groups to a college environment, right? So assume that you have different departments in a college. In a JNNCE, you have computer science, you have information science, we have mechanical engineering, we have MBA management department separately, right? So assume that in this in a virtual cloud, in a VPC, within a VPC, you want to create a separate departments, right? Department workloads, department applications within a VPC, right? If you consider VPC as one college, then you can consider each department as one subnet. And then security groups you can assign to a separate subnets and separate machines within a VPC, so that only the computer science engineering students will get an access into that particular VPC and a subnet and a services, right? So analogy. Yeah. Go ahead, Lipsa.
Okay. So, okay, now talking about security group. Security group is like as I said, it's the firewall in which you decide what kind of traffic you want to allow, and whatever you don't mention is not allowed. If you don't want to allow SSH traffic for Linux, that won't be allowed. As of now, only TCP traffic for RDP, remote desktop that you want to take for Windows machines is only allowed. No other traffic will be allowed. So based on what kind of network traffic is coming into your network, you decide, then you allow the traffic accordingly. Best part of security, who can reach out to your resources, you can decide by providing a value in the resource source. As of now, my traffic is coming from the internet because I'm connecting from my laptop to a cloud instance on the AWS. That's why I'm going via internet. So my laptop doesn't have a public IP. My laptop's IP is not registered in any domain. So it's not a public IP or a globally defined IP. It's not a fixed IP. So I cannot use this. I cannot use, that's why I went for 0000 because it's coming from internet. So remember again, one more key term, 0000/0 represents internet, public, global. Whatever comes from global goes to global, or anything global you want to represent, that represents 0.0.0.0/0. Similarly, you can edit rules, you can add more rules to it, or remove whatever is existing, decide whatever, plan, and accordingly you configure. Now, yeah, we discussed about VPC, subnet, security group. Yeah, let's talk about elastic IPs. Elastic IP is nothing but a public IP which you can reserve from AWS and then use for your resources. When you create an EC2 instance, by default, as you see, I created an EC2 instance, AWS gave me an IP, which is a private IP, is this one, okay? And if I choose to have a public IP, I selected that option and I created the instance with a public IP. But I told you elastic IP is also a public IP. Then why is the need to have elastic IP in the first place? Because when you create an EC2 instance, as usual, you get a private IP, which doesn't change. But when you assign a public IP, it stays attached to your instance as long as you have your instance in running state. But the moment you stop your instance and the next moment you want to start it, immediately or after a while, doesn't necessarily mean 100% sure that you will have the same public IP with your instance attached. Possibility is there, very minimum, but still there is a possibility the IP address will be changed. So if you have google.com, which has a public IP somewhere, and you gave the IP address to the DNS servers or to the end users, that okay, go ahead and put this IP address to reach google.com, and for a moment, for maintenance or for some reason you stopped your instance and then you restarted, there is a new public IP. But when the end users hit the same public IP, they are not able to reach google.com. Maybe it will go to some other server wherever it is attached, or it may end up with 403 error, not found or something. So if you want a static IP, always available IP for your cloud machine, you use the elastic IPs. You provision the elastic IP and use it for your instance. If you are provisioning a elastic IP, that means you are blocking it. You are reserving the elastic IP from AWS. And if elastic IP again is free of cost, but if you are reserving the elastic IP from AWS and not using it, then it will cost you. So make sure if you're not using elastic IPs, release them. If you are procuring them, use them with EC2 instances. Okay, now our EC2 instance is ready. Let's connect to it. There is a different connection method for Windows and Linux, and there are different tools available. For Linux, you can use PuTTY, and for Windows, you can use normal RDP MSTSC will connect. And for Linux, as you remember, when I created this instance, I created a key pair as well, EC2 key pair. That's a public-private key pair. The public key is available with AWS, and the key we downloaded is the private key. So whoever will create the instance have the EC2, the key pair, owns the private key. Make sure if you are creating EC2 instance and if you are having a EC2 private key, whenever you are using it, make sure you are having it in a secure place, or delete it if you are not using it, and delete from the AWS console as well. Make sure that's very important, because if it gets compromised, multiple instances can get created and using those key pairs, and you might end up paying a lot of money. So be careful with those things, maintaining key pairs and passwords and stuff in terms of cloud. Okay, let's connect to this one. And to connect to this, I need to have a password for this Windows machine. I have the key pair. I'll connect. It will connect my system, my laptop to the Windows. But what is the password? What is the administrator password? The initial password to connect to that. For that, I'll go for the option connect. It'll ask me get password. Okay. Then remember, I'll go for the option connect, get password, choose the file, and here I'll choose the file I downloaded. Where is it? I downloaded, right? When you download the key, at first it is a .pem file, and for Windows, .pem file will work, but for Linux, you'll have to convert the .pem file to .ppk file. See, the file got downloaded with an extension .pem, and you need to convert it to .ppk for Linux, SSH connection through PuTTY, or there is MobiX term. There is another tool which provides RDP and SSH both. It's a freeware. Use it wherever you can. Now I need to decrypt the password. I cannot use this big password to connect my Windows. So I'll decrypt the password, save it somewhere. Okay, a lot of information. Save the password, close it. Now I'll okay. You can either download the RDP desktop file, or you can download the RDP file, or you can normally do MSTSC. So this is nothing but just the MSTSC with the IP address already pre-taken for it. Okay, so connect. I want to connect to this machine. You see, EC2 hyphen the IP address is already taken, and I need to provide the password for the administrator user, which is the initial user for the system, because there is no other user is configured already for it. And here you go. I'm connected to the cloud virtual machine. Are you able to see my screen or? Okay, hold on. DJ, are you able to see my screen that it's connecting to the Windows machine? DJ, can anyone confirm whether you are able to see my screen that I'm connected to
Yeah,
a virtual
yeah,
machine? Okay,
yeah,
great.
Lipsa, you're not able to
So
see.
this is like just another machine, like my laptop, like your own laptop, like your computers. This is another machine. Go ahead and test, experiment, develop, run your production, non-production, and sandbox any environment on it, and yeah, work with it. So that's how you create a machine on cloud. You connect. You can install. Okay, on system you can install antiviruses on top of AWS existing security and firewall. You can have your security software installed and have your extra layer of security on it. So yeah, that's about compute. I'll talk very briefly, DJ. I think it's about 12:08. I'll talk 5 minutes more on S3 and IAM. Then I'll hand it over to you for Q&A.
Sure, sure.
Okay.
I think
Let's talk about yeah.
the students what just now saw that how easy, how fast is to get my virtual machine, my server on the cloud, right? So everything is connected through an internet, right? So you need an internet and your server is available up and running. If you imagine, at least when I was studying in 2003, 2003, we never imagined we'll get a server in a fraction of minutes, right? So the concept was just evolving during that time. 15 years back, the POC was going on, the virtualization was there, but the concept of public cloud was not there 15, 20 years back, right? So that is the power of the technology that we are talking, and this is just a beginning, and the technology is evolving much higher. Lipsa.
Okay. So talking about storage service S3. When you create an EC2 instance, sorry, pardon me. When I'll talk about that in the meantime. Let me talk about S3 as well. Sorry, guys, there is so much more we can talk about, but the limited time is forcing us to just talk, make it very concise and brief. Okay, when we create an EC2 instance, it gives you a default disk volume, which is your root volume. Like you have your C drive on your system, where all the image, the operating system gets installed, the necessary system softwares and configurations, registries, and everything will reside in. That's your root device, the primary disk. So similarly, when you create an EC2 instance, it gives you a root device attached to it, which is called EBS volume, being provided by EBS service, which is a sub-service of EC2. It's a sub additional feature on EC2. Provides volumes. So you can create EBS volumes, and when you create an EC2 instance, it comes by default with an EBS volume. While creating the EC2 instance, you can choose how much size of EBS volume you want to attach. That will be a primary volume. Then later you can create and attach volumes to the EC2 instance. I can demo that, but the limited time is forcing me. So you can create EBS volume and attach to your EC2 instance. You can select the EC2 instance actions. Okay, from the volume itself, you create the volume and then select. You can, you see, just before detach option, there is attach volume. This volume is already attached to an EC2 instance. That's why it's not giving an option. If you are creating a new volume, it will give you the option to attach the volume to an instance. You can select that and then browse the instance ID and then choose the instance ID. This is the instance ID, I hyphen, then the instance name. That will be like the instance ID. Every AWS resource will have an ID. For EBS, it is like VOL hyphen, then the volume ID. For instance, it is I hyphen. Get yourself familiarized to these terms. So this is one of the storage options, EBS volume. The other storage option, this is like your system's disk volume that comes along with your system. Sometimes you need extra space. So you buy an external hard disk. In AWS, the concept is S3, simple storage service. S3 is the service in which the resources are like bucket. So the first level of resource you can create is a bucket. You create a bucket, and then inside of it you store objects. It's an object level store, and EBS is block level device, block level storage, and S3 is object level storing. So in this EC2, sorry, EBS, I mean, it's a very frequently asked question. What is the difference between EBS and S3? EBS is block level storage, elastic block storage. So you partition it and then you use it. Once you attach a EBS volume to an EC2 instance, you mount the volume, then you partition it, then you start using it, and then start storing data into it. In terms of files, it's kind of file storage. Okay, inside of the EBS you store files, and in S3 the same concept. You create a bucket, and then inside of it you create the files which will be named as objects. So it's object storage. Okay, so this is just an example of a S3 bucket that I have. Remember, S3 bucket names are globally unique, irrespective of any region you are creating in. If I am creating a S3 bucket name ABCD, Vijay, that's my husband's name, ignore it. But yeah, that's the bucket name. If I'm creating a bucket in my AWS account, and it is created in US East North Virginia region, if you see, but irrespective of where I created which account it is being created in, globally the bucket name is unique, because this is the storage in internet. Not only you can access S3 from within your AWS account, S3 can be accessed from anywhere in the globe. That's why the bucket names have been given to be public and publicly unique. So yeah, keep that in mind. Bucket names, yeah. And one other important thing about buckets is the incoming traffic to S3. It's a one-way ticket. You come in for free, go out of your own cost. So that means when you upload data into S3 bucket, the incoming network traffic is free. You don't have to pay for that. But when you are downloading stuff from S3 bucket, and the amount of volume that is being stored, for that you are paying to AWS. Till 5 GB it is free. Beyond that it costs you. So yeah, that's a free tier tech advantage of it. Again, remember the fact: incoming traffic free, outgoing you have to pay the cost. It's like the hotel accommodation. They give you the taxi from the train station to the hotel, but to go from the hotel to the train station, they don't care. You take your own taxi and go home. So it's like that. So yeah, that's about S3. Now we can go in depth to it, but again, so I'll just talk briefly about IAM, which is again very important feature. So remember, when we create an AWS account, when you create an AWS account, you give your email ID. That's again globally unique, because you create your email ID is globally unique. If you create in Gmail or anywhere, adding Gmail to it again makes it unique for Gmail, and then inside Gmail your email ID is unique. So your email ID becomes the root account, the root user for AWS account. Remember this, very important. When you create your AWS account for the very first time, the email ID that you give for the while the account creation is your root user. And it is highly recommended not to use root user for your day-to-day AWS cloud activities. Create IAM users. So here is the place we end up in IAM service, where you create the users, define what permissions the user will have, and based on that, the users will be able to work in cloud. So why not using a root account? Because root account has the highest level of power on an account you can have. If your root account credentials are compromised, if somebody gets access to your AWS account, they can do anything with your AWS account. They can create any resources in your AWS account, any number of machines. The biggest fraud that nowadays is happening is Bitcoin mining is happening. A lot of fraudulent cases are happening on cloud. So if you are not, again, cloud can be very secure if you know how to use it. It can be very vulnerable if if things slip out of your hand. So so it's recommended you not to use root account credentials, but use IAM user, or there are other ways available. But for a very first level, I can explain to you IAM user access. There are IAM users, roles, groups, but for individual users, you can create IAM users. Well, not a very secure AWS recommended way of giving access to people. But if you don't have any other way to connect to AWS, go ahead and create an IAM user and create the credentials and share the credentials with whoever wants to have access to the cloud account. If you are having a company or organization running and you have people working on the cloud, create one or multiple IAM users based on the number of employees and share the credentials with them. They can have access to the cloud console. But if you have an Active Directory which is being maintained, Microsoft Active Directory, which is if you have a domain and you are maintaining an Active Directory for user and access management, then the Active Directory can be federated. Federated access means something is not yours but borrowed access for a period of time with temporary credentials. That's basically what it means. So with federated access, with using just same Active Directory credentials, you can also log into AWS and have access to it. For now, I'll talk about the users. Okay, before that, user or role or group or anything in AWS, you can give access by policies. So when you create a user, you need to attach a policy to it, because creating a user, it's like giving an ID, creating a ID or a access card. But what the person will be able to access, where the person will be able to go, then that depends on what permission you give them. Like in your college, let's take the same example that DJ gave. If in your college you have computer science and mechanical and electrical, and I give you a access card of your college with your college name, but computer science students should only be able to access the computer science labs and not able to electrical and mechanical, then I need to configure only computer science labs access to it, and not electrical and mechanical. I need to exclude them. So these level of accesses you can maintain by some configuration. So that configuration resides in a policy. So you can attach a policy to a group or a user or a role. So you define the inside the policy what access you want to give. So now in AWS, a policy actually holds. So like I gave you an example, in your access card you define which lab access you want to give. But in terms of AWS, it's like which service and what resources you want to give access, that you define inside a policy. So when you go inside a policy, it's a JSON template. Many of you may already have an idea what a JSON looks like. If you don't, Google it. It's a very good thing to know. If you're already in IT and you want to pursue your career on it, have experience with it. So a JSON template, it's a JSON feature which has how it looks like. Let me open on a Notepad++ for you. Okay. Okay, inside the JSON, if you see it defines what service you want to give access. CloudWatch is a service, DynamoDB is the service, and these are the access that these are the service, and inside the service, what action the user can perform, that you define. So all this is how you define inside okay, this is how a JSON template looks like. So inside the JSON of policy, you define the service to which the user will have access to, and then the action. What action the user will be able to perform. Remember, the action is nothing but also called as operation, also called as the API call, application programming interface call, that the user will be able to perform against the service and resource. So yeah, when you hear about API call, don't get confused. This is what it is. Service and then action. The action is the resource. Sorry, API call. Inside the IAM policy, you have different sections. Inside action section, you define what actions the user will be able to perform. Effect will tell you allow or deny. If you want to allow something, say it allow. If you want to deny something, say it deny. So instead of allow, it will be deny. And then inside of resource, if you are mentioning a wildcard star, that means everything. If you are mentioning a specific thing, then provide the specific ARN, then user will be able to access accordingly. Talking about ARN, very important thing, that will be the very last thing I'll talk about now. So ARN is nothing but Amazon resource name. This is the very gist of, also one of the very gist of Amazon. Amazon resource name uniquely identifies your cloud resources across the globe. Remember, across the globe. Not only in your AWS account, not only in your region, but across the globe, it uniquely identifies your resources. How it is unique? because if I created an EC2 instance, it has a ARN. Okay, EC2 instance gets a DNS, but let me find that ARN. Okay, for EC2 instances, you get DNS, which uniquely identifies your EC2 instance. There are resources which gets DNS, and there are resources which gets ARN. So ARN will have the initial AWS initials, ARN, AWS IAM, then AWS. Then you will have your. Let me see if I have a custom policy. It will be a best example to show you. Very important to know that how it works. Okay, I don't have any. Okay, so the ARN will have your AWS account ID in it, so which will uniquely identify your resource across globe. So if anybody wants to, how you can use the ARN? ARN is not used to access the resource, but ARN is used to work with the resource. Like if there is EC2 instance, you want to access to the EC2 instance, so you use the EC2 instance IP address or the DNS name. But if you want to work on the resource, with the resource, then you use the ARN. You want to configure something, you want to map this resource to something, then that's when you use the ARNs. So yeah, that's pretty much it. I know this is very less, but yeah, I tried my best to cover up the best of things I can. So DJ, all over to you.
Okay, thanks covering the overall AWS services part. So I just want to open up the webinar session for a Q&A. Okay, if you guys have any questions, I request Harish sir or Nirmala ma'am or anyone to moderate it, and then seek questions there. Yeah.
We are ready, sir.
Yeah. So, any questions, students? So just wanted to, since it's a webinar, just please can you raise hands? How many people understood cloud computing? Okay. Interesting. So is it available as part of one of the subject in your regular curriculum now? I see many universities have got cloud computing as one of the optional subject. Do you guys have it, or it's there in next semesters?
There is 7 semesters. Participants are from 6 semesters.
Sorry, I'm unable to hear you, sir.
These students are from 6 semesters.
Okay. Okay.
They are subject in 7 semesters. Cloud computing.
So can I? If you don't have questions, I will ask questions. Okay.
So my question is, on what basis we have to select the availability zones or regions, since there are so many regions and availability zones. So on what basis we are going to select the zones or regions?
DJ, you're going to answer that, or shall I?
Yeah, go ahead, Lipsa.
Okay, that's a good question. I mean, I think with the limited time, I skipped a lot of things to mention, but glad that you asked that. Okay, without doing much ado, availability zones. See, the very first thing that comes into picture when you create a resource is which region you want to create your resource in. And for that, the deciding factor is, let's say you are creating an application, but most of your end users is going to be in America. So you will definitely choose the region as US East 1 or US East 2, as you can see on my screen, if it's still sharing. You can select North Virginia or US West Oregon or US West California, Ohio. There are multiple US. But if your end users is going to be in India, let's say the application Flipkart, which is prevalent in India, or Myntra or Jabong, these are applications for which the most of the end users are in India. So based on the end user's perspective, you choose the region where your application is going to, because the end user's latency to the application matters the most. They are going to access the application and the resources. So first you decide on the region. So that's what affects the most, the deciding factor, which region you want to choose. Then selecting on availability zone, to be honest, it doesn't matter much. But if you, let's say, if you already as DJ mentioned, okay, best example, if you inside that, in the segmentation itself, in the VPC, in the availability zone, it's like the subnets. So which subnet you want to create your resource in, if you already have if you have two subnets for your application, and there are two other subnets which is being maintained by for a different application. So if you remember, a subnet resides in a single availability zone. So while creating the resource, as I'm demonstrating on my screen, it asks you on a page, configure the instance, in which you select the subnet which otherwise selects the availability zone for you. If you see subnet ID, then the availability zone. If you have 4 subnets, in which 2 subnets are for some application, 2 subnets are for some other application, doesn't necessarily mean all 4 subnets will be in different availability zones. All 4 subnets can be in same availability zone or in different availability zones. But if you, based on where your application is, based on where you have configured the other resources, that decides where you want to create the upcoming resource. Then it really matters which availability zone you really want to choose. If my application's resources are, let's say for computer science, I'm using 2C, and for electrical, they're using 2A. And all my computer science machines are in 2C. So in that case, I'll definitely choose 2C. But network latency wise, network flow wise, everything is is same. The other important factor is, when you create a VPC, you give IP range. Again, when you create a subnet, you also give a IP range. So it's also true that inside of VPC, you can connect from any availability zone resource to other availability zone or other subnet resources without any network latency delay. You can communicate through the private IP. But just that, for a better management, for a better segregation, and for your application's configuration perspective, if you want your resources, if you want your computer science resources to be in 2C, it's a personal choice or personal preference. But the very important factor that should matter is where you are choosing as the region, because that's what takes the network latency. But
And
otherwise, 2C,
and
yeah.
also just want to add that choosing a region depends on your security and compliance requirement. Okay, as she was mentioning about Flipkart, right? So some customers, especially banking and insurance companies, will say my data, my user data should not go out of my country, right? So in that case, you need to choose a region within the country itself, so that the customer's data, the should remains within the country itself, right? So there are a lot of compliance and security guidelines will guide your regions and stuff like that. Okay, availability zone can be any within the same region, but a region decision also is very important based on compliance requirements. And one beauty of it, I will tell you, you will not come to know where exactly the applications are running. For example, if you choose Mumbai as your one of region, right? So you will never come to know within Mumbai where is the data center. Ultimately, the computing resources and these services are rendered at the center, right? But you will not get to know where it is. Okay, so that's the level of secrecy that the CSPs will maintain. What you get is what they have promised as a service. You will not get to know what it is. Okay.
Thanks. One more question is, I'm in India and I'm going to select the region as US, and I'm going to place my data there. So what are the data governance policies with respect to the government state that they have so many data governance policies? So which policy is going to apply? Is it Indian data governance policy, or the country where my data is set?
Country specific policies will be applicable, and also there are industry specific guidelines and compliance will be applicable for the services.
You mean to say like the government policies will not apply to the cloud at all?
Yeah.
For different countries, there are different compliances that applies to the cloud, because all in all, the data center resides in a country and it has to to be compliant with the government rules and regulations and policies of that particular country. So the compliance policies in India may not be the same with US, but they try to keep it intact and secure as much as possible.
Questions?
Okay. Any more questions?
Yes.
Okay, I would like to add one thing. Okay, go ahead, ask the question. Go ahead.
Go ahead.
I would like to have the industrial visit so that we can get a real life experience.
Can you please be louder? Sorry, I am not able to hear.
Sir, we would like to have an industrial visit so that we could have a real life experience about the cloud.
Industry visit so that you can real time. I will tell you one fun part of cloud computing. Okay, you will never get to know where the cloud resides. That's the beauty of the cloud. You will get to see the rains. Yeah, industry visit. Yeah, definitely. Madam is working on that, so I will update you in some time. But if you want to see the cloud where it is, you will not get to know. But your application will run, and you will get your application for sure.
The whole point of using cloud is not having an industry itself, maintaining everything remote and accessing it remotely and get your job done on the cloud itself. So if you want to have an industry visit, have a cloud account, or DJ create an AWS account for them. They'll visit the cloud account and explore all the resources that is there.
So I think if you guys don't have a subject as a cloud computing in your curriculum, right? My suggestion would be to spend some time in googling around fundamentals of cloud. I think whatever Lipsa is trying to cover in less than 2 hours is not sufficient. Okay, and the industry has moved away from traditional IaaS market to a platform market and to a software as a service market, right? So you will be surprised that you don't see a server who is processing your request, right? For example, if you look at Lambda, what happens is it will process your request based on need, right? And then automatically shuts down. There is no server at all. You'll be surprised how it happens, right? So the way you don't identify data center, you don't find your server, but your work is getting done. That is the power of technology. That's the power of platform-based services. Yeah, definitely.
To add,
Take your point, and I will work with Nirmala Madam. That's in my target list for industry visit. But cloud computing, no CSPs will allow anybody to enter, and nobody will tell you where the data center is. Okay.
Thank you, sir.
Yeah.
okay, just to add to that, while I was speaking, I stressed out on multiple places that these are the key terms you need to keep in mind, so that in later time, whenever you want to explore or you want to study on your own or you are working, it will be really helpful. So that was the reason I really stressed out on few points. Keep in mind, or this is the key feature, or this is the term that you need to this is the terminology that you need to familiarize yourself with, because terminology comes in first when you are acquainting yourself to a new environment, to a new thing. So there are definitely new terminologies that are there in AWS. So there are few which are primary, there comes secondary, there are few optional, additional for your, to help you with your environment. But yeah, familiarize yourself with those terms, and and later time research with them.
Okay. Any more questions? Harish sir is in with the mic.
Yes. Narendra is here.
Sorry, Narendra sir. Okay.
Any further questions?
Okay, one thing I wanted to highlight, Narendra sir, any technology for that matter, right? So the today's world is all about learning by ourselves, right? The way current education sector is getting transformed, right? As a teacher, as a student, each one of us has a role to play. So since you are at a third year engineering, right, take up some topic, and once a week, okay, within a cloud computing, I will cover AWS, some of the services, right? AWS instances, right? Or S3 or VPC, right? So take up one subject within a cloud and start giving sessions to your own buddies in a college, right? So promote the peer learning so that you will get confidence and also you learn and others also will learn with it. So that is a fundamental idea for discussion class association. We want to promote peer learning. We want to promote students to become teachers.
Definitely, sir. We look forward.
And
Any
I
further
met
questions?
principal also sometime back when he was in alumni meet, and also I visited the college last quarter. And sir also has told that this is already being practiced in JNNC. So that really helps to students to kind of come up and then learn themselves and also become a teacher.
Nice, sir. Is there any question? No more questions from this side.
Okay, if there's no more questions, I wanted to thank Nirmala Madam, Narendra sir, Harish sir, Kunte sir, and all the patient listeners of JNNC Computer Science third year students, and also wanted to thank Lipsa for spending 2 hours and preparing the PPT and presenting to our college. And thanks a lot, Lipsa, on a weekend. I know in Bangalore, finding a weekend is very difficult, out of which you took off a day and spend time with our students. Thanks a lot. And thanks a lot
TJ,
to the college
anytime to help.
as well.
Always up to help you.
Thank you. Thank you, guys. Have a nice day. Have fun. Enjoy.
Have a nice weekend. Happy
Yeah.
learning.
So be online. We will formally conclude this session.
Yeah. Sure.
Thank you all.
Sure.
I would like to sum up this session. Actually, 2 resource persons they have addressed this session, Dhananjaya sir as well as Lipsa. So they mainly focused on the cloud services, studying from the types of clouds as the services of clouds, as well as taking some real-time examples, EC2, S3, as well as AI. So you guys just need to focus on this one because you have in 7th semester an elective subject by the name called cloud computing. So if you are really interested, you can take the help of this team. I hope, sir, you will be helping for these students for coming
Sure.
semester.
Definitely, sir. Definitely. Anytime.
So on this occasion, I would like to thank both resource person Dhananjaya sir as well as Lipsa ma'am for guiding us properly. Thank you, sir. Thank you,
You're
ma'am.
welcome.
Thank you.
Thank you, everyone. Again. Bye.
And also just wanted to highlight the session is being recorded WebEx, and I will share you the link for your references, sir. Yeah.
Yeah, that's good, sir. Thank you, sir. Signing out, sir.
Yeah.